Hello guys, welcome to your own channel Teach Me Computer. To get latest videos, to write programs for computer and to learn how to code, please subscribe my channel and press the bell icon to get the latest videos. Also like my videos, comment in the comment section and save the important videos in your playlist and share the videos with your friends. Thank you. Hello guys, welcome to your own channel. Today I am going to teach you about machine learning. Um According to its name, machine learning, a machine is going to learn something about data, and then after it will be capable to make decisions accordingly. In .NET, Microsoft is providing ML.NET to create machine learning applications in .NET applications. ML.NET gives you the ability to add machine learning to .NET applications in either online or offline scenarios. With this capability, you make automatic predictions using the data available to your application. That means we can have capability in our application of prediction. The predictions will be made after analyzing past data. Okay, machine learning applications make use of patterns in the data to make predictions rather than needing to be explicitly programmed. This is clear that we do not need to program for prediction. ML.NET analyze data and follow data pattern and is capable to predict accordingly. That means data is important for the prediction, so quantity and quality of data is important to improve the predictions. If there is low quality of data and less quantity of data, the predictions will be not good. Central to ML.NET is a machine learning model. The model specifies the steps needed to transform your input data into a prediction. Some steps will be followed to transform our input data for further analysis. Then after we will evaluate and will be ready for the prediction. Model will be ready for prediction. With ML.NET, you can train a custom model by specifying an algorithm. The model will be trained for data as per specific algorithm that it needs, or you can import pre-trained TensorFlow or OnX models as well. Once you have a trained model, you can add it to your application to make the predictions, right? ML.NET runs on Windows, Linux and Mac OS using .NET Core or Windows using .NET Framework. For Windows platform, we can either use .NET Core projects or .NET Framework based projects. And for Linux and Mac OS, we have .NET Core, right? Examples of types of predictions you can make with ML.NET. What types of predictions we can make? Classification or categorization. Automatically divide customer feedback into positive or negative categories. Right? Next is regression, predict continuous values. This scenario is used to predict the price of house based on size and location or other parameters to improve the prediction accordingly. Not only price of house, we can also determine the price of product or other things as well. Anomaly detection, detect fraudulent banking transaction, we can predict as well. If we want some recommendations, suggest products that online shoppers may want to buy. This type of recommendations will be based on previous purchases for online shoppers. Time series sequential data, it is useful to forecast whether product sales. And next is image classification, it is useful to categorize pathologies in medical images. Before we move to write machine learning program, first of all we will look into ML.NET architecture. An ML.NET application starts with an ML context object. ML context is similar to DB context in MVC applications. This singleton object contains catalogs. A catalog is a factory for data loading and saving, transforms, trainers, and model operation component. Each catalog object has methods to create the different type of component. In the catalog, we can do many things. First is we will load data and save. That data will be useful for further use. Then after we will prepare that data for training in the algorithm. As I told you, we have these different algorithms. We can use one of them as per our need. After training the model with a particular algorithm, the model is ready to use. We can use that model in our application to predict for predictions. Now let's move to model builder. Now we are going to write a program in .NET using ML.NET model builder. That is graphical Visual Studio extension to train our model, to build, train, and deploy custom machine learning models. Right? Things that we discussed earlier can be done by this ML.NET model builder. Model builder uses automated machine learning, AutoML, to explore different machine learning algorithms and settings to help you find the one that best suits your scenarios. It will help you to find the best algorithm that you need according to your scenario. You do not need machine learning expertise to use model builder. All you need is some data to analyze and a problem to solve. Model builder generates the code to add the model to your application. So this will be useful for you because you do not have expertise knowledge in machine learning, so it is a good choice for us to start machine learning applications. Let's start. First, what we need is either we need Visual Studio 2007 15.9.12 version or later, or we need Visual Studio 19. So if you have Visual Studio 2017, then check your version from here. Look at here, I have 15.9.18. So 0.12 or later is okay. If you have version lesser than 15.9.12, then update your Visual Studio 2017. If you have 2019, then it's okay. And also I have downloaded ML.NET Model Builder extension that we will use to write our application. Okay, and also download ML.NET Model Builder extension. Right, and you also must have .NET Core 2.x. Let's start machine learning in our .NET Core application. First, go to project, choose .NET Core, console app. You must have .NET Core installed on your system. I am writing my ML app here and press enter. From here, right click on your project, go to add. There must be machine learning option here. Click on here. We have ML.NET Model Builder, which has different scenarios. We need to choose one of them. I have discussed with you. So let's decide which scenario we need to choose to train our model. We have taxifare CSV file. ML.NET supports .csv, .txt, and third one is .tsv file. So three files are supported by ML.NET, and also we can connect to SQL Server. I have .csv file downloaded from internet, Microsoft website for machine learning application. Here I have comma separated headers and comma separated data. This is the first record I have. In the first column I have vendor ID, then rate code, passenger count, trip time in second, trip distance, payment type, and fare amount. In first record I have vendor ID CMT, rate code is 1, and passenger count is 1. Here I have 1271, which is trip time in seconds, how much seconds has been spent in the trip. And next is trip distance, 3.8 kilometers, and CID is credit card, or this is cash. cash payment or credit payment. And next is amount, 17.5. This is amount. Okay, this is 8 is amount, 8.5 is amount. Okay, we are going to predict if someone if a passenger is going to some place, for example it is 3 kilometer, or either it is 4 kilometer uh, far, and going to pay credit or cash, then what will be the amount, uh, fare fair amount to pay. We will predict fair amount. Okay, so for this we have, first I am going to close this file so that I can use it. Okay, so price prediction will be here. Predict a numeric value for your data. I am going to predict the price for fare. I'm going to here I have two options. I can connect to SQL server, or I can choose file. I have a file. Here I have a project. Here I can create a folder called data, right? And open this project folder, and inside data folder I am going to paste my file. I have taxi fare file. I have pasted here, right? I have available now in my project. Further in the data I am selecting my file. Next, column to predict. I need to predict price, so fair amount I need to predict. And six columns are selected as features. What it means is, I am using this column to predict. I am going to predict fair amount. So other fields are going to support to predict. So these columns are called features in ML.NET. Okay. So you can see data here. Now we are going to train our model. We have data selected. It is ready to train. Okay, let's go to train. Now time to train. How much time we need to train? It depends on file size or records. We have only 2 MB of data. According to Microsoft, let's see how long should I train for. If I have 0 to 10 MB of data, I should set 10 seconds. If I have 10 to 100 MB, then 10 minutes. If I have 100 to 500 MB, then 30 minutes. Then if I have 500 MB to 1 GB, then 60 minutes. If I have 1 GB plus, then 3 hour plus should be time to train our model. I have 2 MB of data, so I will have 10 seconds only. Here you can see I have lesser than 10 MB of data, so 10 seconds are enough. So let's train our model. It's training. You can see output here. It's using different algorithms in training. Finalized. Okay, you can see 5 algorithms has been used. Now we are going to evaluate. Let's see. This is the result of training. Regression, as I told you before, regression is used to predict the price. So uh, our model builder has chosen regression automatically from all of our algorithms. Let's see top 5 model explode. Here we have top 5 models. Model that is nearest to 1 has is appropriate. Model that is nearest to 1 is appropriate. So this is the nearest one. Here we can evaluate. Let's choose. We can test our prediction here. We can evaluate either a model which has been trained is proper or not. We can test our model here. Let's choose the default values first. It is giving us Fairmount 16.82. Let's check our data. This is the first record. It is predicting a 16.82, value is 17.5. Here it is nearest to 17.5. It has predicted that the amount must be near this. Okay, if I have 3 kilometer distance, then this is the predicted amount. Okay, predictions are 15.77. So next, after, let's check one more time. The amount will be same. Okay, we can also increase the time. If we are taking more time, then affair is going to increase. Okay, so predictions are same for number of passengers count. Next, generate code. The ML.NET model builder generates code, so we do not need to worry about code. It will be automatically generated. I am generating. Add machine learning model and projects and references for model consumptions. ML, my ML app, ML.model, and training testing my ML app, ML.console app to your solution. You can notice here that my project name is my ML app. It is appending ML.model and ML.console app after my project name. So there will be 3 projects after I click on add projects. I have opened here. Let's see what has been generated. In my application, that in my project that I created earlier, has simple main method and a single instruction to print hello world, and in the model project I have model trained model. The model which is trained is inside ml-model.zip file. This model is available to consume in multiple applications. We can consume anywhere using the class consume model. We have this is the class we will use in our application. This class is providing us predict function to use. You can notice here there are model input as a parameter and model output as a result. So we have two classes here which is used in the predict function. Let's see what is inside model input. Inside model input we have all the fields of our data, that is vendor ID, rate code, passenger count, trip time in second, trip distance, trip type, payment type, fare amount. Okay, and this is a column number which is starting from 0. Okay, and then after we have model output which is the result after prediction. Let's see what is inside it. This is the score. This is going to show us the score of prediction. Let's see the console app here. Here we have a model builder. We have code. Let's skip this to make our tutorial simple. Now let's build our project. Okay, let's see NuGet packages this model is using. uh, you can see here Microsoft ML and fast tree has been used, as we have seen that fast tree algorithm was having the best output which was near to 1 after training our model. So it is using Microsoft ML and ML dot fast tree packages for our application to run. Now you can see all the exceptions has been resolved. Now in our application we will consume this model, right? So let's see how to consume this. First we will remove our statement. We have to create model input. If I have passenger count 1, payment type is credit, trip distance is around 1200, 3 kilometer. Trip time in second is 1200 seconds. Okay, and rate code is 1. Vendor ID is 1. Then what will be the fare? Here I have string. Okay, now we have where output equals to consume model dot predict, and in the prediction we are going to pass output input, and let's see the output. Now here you can see I have input provided for passenger. I have this new passenger with the following details, and my consume model is going to predict for the given input and providing the predictions accordingly. My predictions are inside a score, and after saving I'm going to play this. Here you can see if my passenger is going to travel for 3 kilometer and going to spend 1200 seconds, and he has to pay 14 rupees. Okay, let's see if he is correct or not. Let's dig into our data sample. If there is 1200 and time in seconds and 3 kilometers, predictions are 14. It's good prediction. Let's change values. If I am going to ride for 4 kilometers and here it is 1500, then it will cost 18 rupees. So here let's see, okay, if it is 4 kilometer, okay, it is near to the 3.8 and near to it is about 1271. So the predictions are near to the data we have provided. If we want to improve our predictions, we can include features. As I told you that the fair amount is a label which is the prediction column. We are predicting fair amount here, and rest of the columns are treating as features. So ML.NET runs through features uh, to and train and get trained with these features and predict accordingly. If we have more features with more data, and the prediction will be more accurate. So that's it. Thank you.